Stellar astronomy isn't just the study of faraway stars. After all, there is one star right in our neighbourhood: the Sun. Our Sun is a huge sphere of hot, electrically charged gases or plasma, measuring over 1 million kilometres in diameter. From our vantage point, the Sun might appear to be unchanging, but don't be fooled into thinking it's a tranquil and featureless ball of gas. Take a closer look at its surface, called the photosphere, and you'll see it resembles boiling water bubbling in a pot. By studying the colour or wavelength of the light emitted by the photosphere, astronomers have found that the temperature of this part of the Sun is about 5,500 degrees Celsius. The Sun's plasma is continually moving around, helping to create the Sun's magnetic field, similar to how a moving current in a wire does. In the 17th century, astronomers noticed that the Sun often has temporary dark spots on its surface. These features, called sunspots, mark regions of strong, localised magnetic fields and come in a variety of sizes, with some easily many times wider than the Earth. They can change and move around the Sun over a few hours or days or even months. Sunspots can sometimes merge to form an even larger sunspot. Their dark appearance tells us that sunspots are much cooler than their surroundings, having temperatures of only 4,000 degrees Celsius. Astronomers later realised that the number of sunspots increased and decreased approximately every 11 years. Part of the work that astronomers Annie and Edward Walter Maunder did at the Royal Observatory Greenwich was to photograph the Sun every day and to track the location of these sunspots. They found that at the start of the solar cycle, the Sun has a few sunspots that appear between the Sun's poles and equator. New sunspots then form closer and closer to the Sun's equator as the cycle progresses, and go back to where they were when the cycle starts again. The result of their observations was this diagram, which looks like the wings of a butterfly. It's not just the number of sunspots and their locations that change over the solar cycle. The Sun's activity increases along with the number of sunspots, as the Sun's magnetic field gets more and more complicated. When field lines snap, they release a sudden burst of energy as a bright flash of electromagnetic radiation in a solar flare, or as a release of solar plasma and magnetic field in a coronal mass ejection, or CME. These CMEs meet obstacles as they flow out to the edge of the solar system, such as the magnetic fields of planets like the Earth. CMEs can help make the northern and southern lights stronger and really impressive to look at, but they can cause serious problems too, like disrupt radio transmissions, cause power outages on Earth, and damage satellites. Radiation from solar flares and CMEs are also a danger for astronauts and airline passengers and pilots. As we become more reliant on technology, and as our ambitions to go to Mars get more realistic, it gets even more important for us to understand how the Sun influences space weather, so that we can protect ourselves from the next solar superstorm.